Okay. I need you to understand that a huge part of what we're getting into is factoring. Very large part of what we're about to get into is factoring. Have you had to factor before today in this class? Hell yeah. So it's just going to become a little more everywhere. Okay. Have you guys tried this problem yet? To do the derivative, to get the zero or undefined slope? Have you guys done this yet? If you haven't done this yet, do it real quick. Go for it. I'll wait. Hey! All right, I'm glad you found a seat. Yeah. And just, can you guys please, does anyone, everybody sees that's x to the 2/5. That is not 2 divided by x to the 5th, yes? Okay. Sort of start catching up to you guys. So real quick, is this roughly where you guys find yourselves? Yeah. 2/5 comes down, times 5 is 2, power goes down by 1. This is an easy thing to miss. What is this all about? Why is that there? Why is that -1 there? Yeah, this is the chain rule for this, yes? Yep. Inside's more than just x. Its derivative is -1. Oh shit. Remind me, when do we actually do chain rule? When does chain rule happen? When does chain rule actually happen? No, it happens all the time. It's just if the inside function is more than just x, then something shows up. But otherwise, it's just 1, right?
Well, technically you do it anyway, but it doesn't complicate that.
Exactly. It just becomes 1, so it doesn't change anything. So, just to make it easier to teach, we didn't want to teach chain rule first. We wanted to teach more basic stuff, and then we went, oh, chain rule. Oh shit. Just splashed these grades all over. You're welcome. Sorry. All right, so what do I have to do now? I have to clean it up a little bit. Oh, let's see, -10. Okay, just that was a little cleanup, right? The 2 times 5 is 10, I can get the negative out there, right? What do I do now? Considering, now if the instruction said find the derivative, you could circle that shit, you're done, right? Because how much I do with the derivative depends on what I'm asked to do next. So in that case, I'm not asked to do anything. Now I'm asked to find where this is 0 or undefined. So what do I need to do with this? Set equals 0 and then factor, yes. And that's the part I was talking about. A lot of the problems are going to involve this. They're going to involve taking derivatives, taking second derivatives, factoring what you get. You can see where those things are 0. What can come out? Yeah, 2 x to the I'm sorry, I can barely hear.
To the power of -3.
Yes, because we always take out the smaller power, correct? We talked about that a while back. Just trying to get you ready for this. So you take out the smaller power always when you're factoring GCF stuff. Oh shit, what did I just do? Is everybody okay? Yes. How many 6 minus x is going to take out?
1.
Good. So what's left in this term? 2's gone. This is gone. One of these is gone.
So 6 minus x.
Yeah, I got one of those left. Minus, what number's left? 5. I took this away, correct? He's gone, and then what's left here for x's? Nope. When I take something out, I'm dividing it out. When I divide things with power, like bases with powers, you subtract the base, the powers. So what is 2/5 minus -3/5?
Oh, right, yeah.
2/5 plus 3/5.
Right, okay,
Red fifth, blue fifth.
yeah. 1.
Thank you. It's 1. Yeah, so the way I got it written is it there. That kind of thing happens all the time when you take derivatives. Think about why that makes sense. Where the shit did -3/5 come from? Where did it come from? Where did -3/5 come from in this problem? Not like in general, not like, well, mama fifth meant daddy fifth. No. Where did -3/5 come from in this problem mathematically? Where did it come from? You can, come on. Where did that come from? Yes? I subtracted 1 from 2/5. Yes? So of course 2/5 minus -3/5 is the one that I messed up. Because that's why when you take derivatives for this kind of thing, that kind of thing is going to happen. You're going to take out the smaller power and you're going to be left with the whole number power. Because of the way that derivatives work. It's not like I made the problem so that's going to happen. No, it's just going to happen. It's going to happen all the time. Very helpful. So what happens with this business then? What can you do here?
6 minus 6x.
And then I can take a 6 out. And I'm done. I'm done factoring. Now I can answer the question.
What happened to factor?
Do it again. What happened to what?
Hold on, how did you get 12?
Okay.
Oh,
First question I heard was what happened to the 5x?
Now I heard the connection, I'm an idiot.
Okay, no, stop. Don't talk about my student. Then what did I do from here to here?
6, yeah.
And where did I put the 6? Yeah, okay. Don't try to decipher what I did. Just do it yourself, right? It's really hard to guess what somebody did. Just do it yourself. And you go, oh shit, that's where the 12 came from. Okay. Can somebody tell me, when is this 0? No, careful. No. At 1 and at 6, yes?
And it's 0.
No. Stop for a minute. How's everybody doing? Are there still lingering questions? Go ahead.
I have a question. I got lost, but I got the same answer still.
Oh. Where are we at? Oh, here. take out an x to the negative 3/5. Oh, there's him. You didn't lose him. You just right. X to the negative, you just take it out. I mean, how do you factor this? You take out what? What do you take out? If you want to factor that, how many x's can come out? Smaller power. And then when you take something out, you divide it out, you subtract 3 from each power, yes? What's the smaller power in there? Just like we did here, you could take a negative 3/5 power out on the x, right? Okay. So it's 0. So the slope is 0 at x equal 1, x equals 6. Does everybody see those two things? Why is x equals 0 not part of that answer? Yeah. Where would 0 come from? X to be negative 3/5. What's a negative power mean? Flip, so it's on the bottom, and then when the bottom is 0, the slope would be undefined. Yes? Be really careful about that. Your brain's going to go 0. No, you're going to have negative power, brain. Man. So if that was 6 minus x to the negative 1, x equals 6 would be a place where it's undefined. Why is it important? Because we're going to graph shit from this information, yes? And if I don't have it identified correctly, undefined should mean something weird happens to the graph there, yes? So it's important for me to know where that is if I'm going to graph this stuff by hand. And 0 is nice. 0 just means, oh. So maybe it turns, or maybe it goes, oh, like that. 0 is awesome. Undefined is like with the shit. It could be a few things. It could be an asymptote. It could actually be something where it goes infinite for a second. Wow. Wow. Yes? It's like Goku with an Ultra Instinct and a normal. So it's undefined at x equals 0. So let's do this. Let's all watch Jeff try to remember his various passwords here real quick. I want to graph this in Desmos and see what happens at those locations we just figured out. I guess I just need one level of password. There, okay, good. Come on, Chrome. Come on, Chrome. All right, where was it? 5x to the 2/5. 6 minus x. No, Jeff, that's too much shit up there. 6 minus x squared. Okay. So there's 6. That's doing what it's supposed to there, yes? We said it was going to have a 0 slope. That's exactly what I would expect to see. What's this going to be? What's this? What's this going to be? That's going to be x equal to 1, because that's the other place where the slope went flat, yes? And where was the place? 0 is the freaky place, yes? Oh, man. All right, just zoom out, Jeff. Okay, let's look at 0 for a second. Let's zoom in at 0. I think this is Desmos freaking out. I don't think Desmos actually graphed this correctly. That's interesting. There we go. Yeah, this is Desmos. I'm sorry, guys. Don't look away for a second. Everybody's getting sick. Very strange things happen at 0. Yes?
Yeah.
And that's Desmos is just sort of giving up on it. I'm curious now if our graphing calculator can handle it better. Oh, definitely not you. You're dead. Okay. I appreciate your patience. Yeah. Put it, yeah. Oh, he's thinking. Oh, Oh shit, you guys can't see what I'm doing. He's thinking about it. All right, there we go. It looks, actually, believe it or not, it looks better. What was the, I should have paid more attention.
125 is where it capped out.
You guys kick ass. There we go. Yeah, I don't know why Desmo's crapped out there. So, the really tricky thing that's happening at 0, and this you still can't see this, and I'm sorry. Oh, I know what to do. I know what to do. Alright, shit, I don't need this much. Alright, let me explain what I just did. Stop. I divided by 100. So I made all the shit kind of compress. I didn't change anything about the behavior of the graph. I just made all the outputs 100 times smaller. So now I can zoom 6 this bad boy. There we go. Boom, boom. Sorry, I'll stop. Weird shit happens there, yes? So let's zoom in. Zoom, box. I appreciate your patience. I appreciate your patience. I hope somebody out there shares my curiosity. You know, like whatever makes me pass. Be quiet. Here it comes, it's coming in there, and it goes in there, and it goes. Smack! Do you see that? What is that? That's a kink. That is, on one side, what is true about the slope? The slope is very what? The slope is very negative. And then immediately it becomes very positive. Again, not a plane you want to be on. We're all dead. We're slammed up against the side. Gross. Yes. Sorry. Sorry. I just wait for somebody to go, that happened to my thing. Oh, sorry. Alright.
Oh, it's like you are making toast on I got a frying pan or something. You jerk it up so it slams against the pot, goes flying against the wall.
Well, it might work, but at least less people die in your example. So that is a kink in the wild. Yes? You guys have seen them in pictures and the book and whatever, but there's a kink in the wild. I'm surprised Desmos, for some reason, couldn't handle that. Maybe the kink happened, I don't know, it gave up. Poor little Desmos. Let's all shed a tear. Okay. So I knew something weird should happen at 0 because it has an undefined slope. Right? It's not differentiable at 0 because the slope is discontinuous. Okay, so that's why it's really important to be very careful as to where is it undefined, where is it 0. 0 is nice or nice. Undefined is weird shit, either an asymptote or a kink or who knows what. Maybe. Okay. So, what I want to focus on today is taking the next step. Now that we're able to do this kind of stuff, let me say this. Where the slope is 0, was anybody paying attention the 2 times I did this earlier? Is that definitely going to be a turning point? No. What's the slope of x cubed? What's the derivative of x cubed? 3x squared. Yes? So what is the value of the derivative of x cubed at 0? Can you guys do this without me writing it? X cubed, derivative is 3x squared. When you plug a 0 in, you get 0. But what does x cubed do at 0? Does it turn? Nope. Yes? Are you with me? What does x cubed do at 0? It goes flat for a second. Millisecond, femtosecond, whatever the shit that means. And then it keeps going up. Yes? So, where the slope is 0, it could turn. If it did this, what kind of point is that? That is a local max. If it does this, that's a local. If it does this, that is a local prank. That is the stupid thing going, no, right? Locations where the slope is 0 is a possible local max or min. Kick ass. locations where it's undefined, same thing. It's a possible max or min. So it could be a kink, and isn't that an accident? Isn't that a local max? On this picture, I think it went the other way. I can't remember now. Shit. Yeah, it came in and did this. So that would be a local min. Yes? But it could do this. It could go infinite for a second, in which case it's not differentiable at that point. Yes? It could go infinite for a second and keep going. That would be not a max or a min. Do you all agree, though, that 0, 1, and 6 are critical points? They're critical values. Yes? And that's exactly what we call them. Are they definitely locations of a max or a min? No, but they're potential. They're the only potential places for a local maximum. Okay. So they are called critical values. Because math people were very creative with our naming. Okay. Yes, let's do this. Let's take this problem a little further then. And then I'll refer back to the graph of it. Can everybody draw a little number line for me somewhere? I got space up here because I'm using a different page. So wherever you got space. I'm going to put my critical values, 0, 1, and 6. Good job, Jeff. I'm going to make this 1. Then you could be 6 and you could be 0. So you put your critical values. Dear God, put them in order. This is an actual number line. You don't have to have the scale. You just have to have them relatively in the right place. I'm going to put above 1 and 6. I'm going to put a Z. Because those are words 0. What am I going to put above 0? Yeah, me. What am I going to? I'm sorry. That was. I'm going to put a U for undefined. Do you all agree that this function is continuous? Do you all agree that the derivative is continuous on its domain? Because it's made up of rational functions. Well, this would be radical function and polynomial pieces, right? So then we had that thing a while back about certain functions are continuous, exponential, trigonometric, rational, blah, 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 yes, polynomial, or obviously. This is continuous on its domain. And of course, what's not in this guy's domain? 0. That's why I had a discontinuity in the derivative at 0. You guys with me? Okay. So, if the derivative is continuous everywhere on its domain, where are the only places it could change sign? So how does a function change sign if it's continuous? If I'm above the x-axis and I want to go below the x-axis, I have to go through the x-axis, correct? So if I want to change sign, I've got to go through 0. And where's the only places it does that? Here and here, yes? And then this is another place where it could potentially change sign, because weird shit happens there, so it could change sign. Okay, let me stop for a minute. I really, really wanted to make sense what we're about to do. If I plug like 2 in, I can see if it's positive or negative, and then it's going to be that throughout the whole thing. In fact, do this for me. Can you plug a 2 in to this? Now watch what you can do. You ready? Watch what you can do. 12 is always positive. When I plug a 2 into this, do I get positive or negative output? Positive. 2 into this, what do I get? Positive or negative? Positive. 2 into this, what do I get? Negative. So what's the value of the slope at 2? Positive times positive and negative is negative. It's negative at 2, so it has to be negative in this whole damn region, because the only places it could change sign is where it goes through 0 or it's undefined. What does that mean about my function? What's my function supposed to be doing between these 2 points? What is this a graph of? What did we just plug 2 into? Slope. In fact, these numbers came from the slope, correct? This is the slope. This is the slope. This is the slope. What is my function doing then between 1 and 6? Decreasing, going down, right? Okay. On a wild ass roller coaster ride. Whoa! Until I divide it by 100. Do you guys see how you can just keep going? What would you put to investigate this region? 7 billion? Yes, I would put 7 billion. So if I put 7 billion, no, I'm sorry. You could put 7 in, you could put 8 in. The number doesn't matter, it just has to be a number in the region you're investigating. So if you pick 7, we'll go with 7. We won't go with 7 billion. Well, listen, this is going to be positive still, yes? 6 minus 7, negative. 1 minus 7, negative. Positive times negative times negative. Positive, so it's positive everywhere there. So forever after 6, this should be going up. I don't know if I want to teach this necessarily, but no, I do want to teach it. I don't know if we have you guys, has anybody ever heard of multiplicity? Multiplicity is just how many times a value showed up. So what do I mean by that? How many times did 1 show up? Once. If there was a second power, I would say it showed up twice. Because it'd be 1 minus x, 1 minus x, yes? So this has got a multiplicity of 1. This has got a multiplicity of 1, yes? And it changes signs around when it's multiplicity 1. Because what does a line do when it hits a 0? It keeps going, it goes through. If it had multiplicity 2 or 4 in even multiplicity, what does x squared, x to the 4th, whatever do when it hits at 0? What does a parabola do? X squared, x to the 4th, when it hits at 0? Turns, yes? So then it would stay the same sign on both sides. If you know multiplicity, this is quicker. Do you have to know multiplicity to do this? No. If I knew multiplicity, I'd plug that in, and then I automatically know that's positive, because I know the multiplicity of this is odd, it's going to go through, it's going to change signs. So if you don't want to take the time to learn multiplicity, I'll cry about that later, but you don't need it. You just plug more shit in, and the people that know it, they can get it done quicker, but you know, it's up to you. What if I got to plug in here? If I didn't want to use multiplicity, I have to put, let's put 1/2. Let me put this up here so we can see it better. So when I put a 1/2 in here, I don't care about the number, I just care about the sign. Positive. 6 minus 1/2 is positive. 1 minus 1/2 is positive. So like I would have predicted, it changes sign because the multiplicity of 1 was 1. It changes sign. The only one that's funky, of course, is this guy. They will always be funky as shit. But what would I plug in to investigate it? Negative a billion. No, I'm sorry, negative 1's fine. So if I plug a negative 1 in, is everybody with me what's happening? Does everybody understand where these signs are coming from? So this is when I plugged a 1/2 in. I'm going to plug a negative 1 in now. What is this finally now if I plug a negative 1 in? It's negative because it's a cube, and it's a 5th root. Those maintain the sign, correct? So it's negative times 6 minus negative 1, positive, 1 minus negative 1. So it becomes negative. Does that match up with the graph we saw? Did it go down? Let's see. Then it went up a little bit. Went down, then it went up forever. Yeah, let's see. Where was it? It was in the calculator. Which one was it? Not that one. He's dead. There he is. Down. Up. I'm zoomed in really weird here. I forgot. Down. Up. Down. Up. There we go. See? Down, up, down, up, down, up, down, up. Yes? You guys kind of with me? Does that kind of kick ass? No? Suck? No? Screw you, Jeff? Okay. Alright, so let me give you this. Here's a little something to help make sense of it. I don't need you for the moment. Like, damn, right in front of me. This one, I think about this. All right, so I want us to start on this side, the side with way too many words. But I kind of like this because then you can just look at it later. Yes, I mean the book basically says the same stuff. To be really honest, I can't remember exactly how the book does this because I don't care. But by the way, we will talk about 4.2. 4.2 is a weird little diversion that we'll talk about in a minute. 4.1 and 4.3 are both kind of leading into graphing functions based on calculus that we do. In pre-calculus, you should have graphed functions based on like end behavior, asymptotes, if you have all of that, right? Remember? So now we're just going to learn more about the shape of a graph. So I started with a really dumb example. That's okay. X squared, we all know it looks like this. Whee! But if you just do the calculus, the critical number is 0. That's where the derivative is 0. It's not undefined anywhere. So I put a little z above 0. When you plug in a -1, you get -2, and you plug in 1, you get 2. So that's negative back there, positive. So it goes down, flat, up. You guys with me? You can always at least do these little arrows. And then if you kind of smooth them out, it looks like a parabola, yes? Which is good, because that's what the shit x squared is. You guys follow? What, does it have a local, let me just throw a word at you. I can't remember if I said this word. Does it have a local extrema?
Yes.
Extremum, so I'm talking about in the singular. Gotta know my Latin. So it has so when I say extrema, this is a quick way to say max and min. Local extreme, just extreme values. It has a local minimum. You can definitely see that shit if you draw the little diagram for yourself, the little arrows, yes? But you can even see it before I drew this. It goes down to this and it goes up from that. So of course that's a freaking minimum, yes? But when you graph, you're like, oh, it's a freaking. So what is the minimum point? You can't go wrong with this problem, 0, 0. Yes? But where would I plug this to figure out this? Good, f of x, not f prime, because at that point, I don't want to know the slope, I want to know the output. Yes? Are you guys with me? Do you remember when I was trying to tell you, be nice to yourself and tell yourself when you actually do a derivative? What's f? What's f prime? Now you start to realize why. Pretty soon we're going to talk about what does f double prime mean. We're going to have f prime, f double prime. You're going to have to know when to plug into which one. Yes? Depending on what you want at that moment. Oh, that's right. Got here right at a good time. We're about to do this. So you can read through all this exhaustive stuff. Blah, 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 blah. I basically just said what I just said. Let's try it for this guy. Go ahead and do that guy's derivative and then try to factor in him so you can see the critical values. Oh. You have to put like a ball return thing. So it will slides back. Yeah. I'll look into that. I'll see if the school has money for that. Probably not. They can't even give us another freaking whiteboard for that. Thank God. Okay. And you all should be saying, oh yeah, Jeff, make every problem this, but you know, I'm not going to. What do you guys get here for the derivative? 20 x to the fourth minus 20 x to the third. And then what do you want to do with that?
Factor 20x.
Yes, factor it. Out comes 20
X cubed.
x cubed,
X minus 1.
x minus 1. So what are my critical numbers? Think of it as values though. Probably say numbers more likely. What is my Cartoon Network? I mean my critical numbers.
0 and 1.
Yes. Remind me, what do those mean?
This changes it.
What do those mean in terms of the graph? There's
Possible turn.
possible turning points, possible local extreme. Yes? I don't know if it's the graph faking me out yet. I have to investigate that. And how do we investigate that? We create number line, sign diagram. Go ahead and do that. Sign diagram. You don't want me singing, I'll stop. Yeah, you got that back. First thing we did was we just finished that last problem, that handout from last time.
Okay.
That's all you missed. Yeah.
I had an appointment to remember.
Now this song's stuck in my brain now. Somehow she saw the sign and then her eyes opened. It's always trouble.
She had a dream.
You're right. Somehow she saw it in her mind. That's a good point. So for those of you who are interested in the multiplicity idea, both of the multiplicities are odd. So it's going to change signs. So what that does for me is I only have to check one region and then I just make it change. If one of them was squared, it would stay the same sign around it. That makes this a lot quicker. Imagine 7 freaking critical numbers and you have to check 6 regions. I'd much rather check one and go bop, 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 based on the multiplicity, but it's up to you. It's up to you. So let's see. What'd you guys do from here?
2.
Alright, plugged a 2 in. If I plug a 2 in, I would get positive times positive. Let me think about it. That's positive. What I would say is that's negative and that's positive because I know the multiplicities and I'm amazing. But if I put a 1/2 in there, what do I get? This would be positive, and this 1/2 minus 1 would be negative. Is that cool? Do you guys see how you do not care about the actual number? You don't give a shit about it for this problem. You just care about, will it be positive output or negative output? So it's negative here, and if I put a -1 in, this would be negative times negative, positive, bam, 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 bam. So it did change signs everywhere as predicted. If you haven't done this yet, can you, underneath that, draw some little arrows indicating what those plus and minus signs would mean? Just like I did above this. All right, let's see. So this would be going up, then it's flat for a minute, yes, for a second. Then it's down, then it's flat, then it's up. So now you have visual confirmation. How many local maxes does it have? 1. And how many local mins? Good, yeah. Where's the local max?
0.
And what is the max?
0, 0.
Yeah, 0, 0. And where'd you plug the 0?
The function.
In the function, yes. And then what's the min?
1
1, and then if you plug a 1 in here, 4 minus 5 is negative 1. If you plug a 1 in here, of course the answer is 0. We already knew it was 0. That's why it was a critical number, yeah? I don't want to know the slope. I want to know where the function is at that moment. So when I plug a 1 in here, 4 minus 5, negative 1. Yes? Okay, all right. So, I'm sorry. Good. Went too quickly. Please let that be not too bad. You guys can take derivatives. You guys can factor. And then this is great. Once you get the pluses and minuses, plus go up, 0 you go flat, negative you go down, and then it's just really staring you in the face where the maxes and mins are. It's kind of crazy. Or you're still copying that much. Okay, here we go. So what I want you guys to do is I'm going to let you work on this problem for a bit. Now, real quick, I want to point this out. Do you guys see how you could make a mistake when you take this guy's derivative, yes? So a while back I realized it's really evil since every other part of this question is reliant on the correct derivative. If you just don't do the derivative right, or you're not even sure how to do it, you can't do the rest of the damn problem. That's kind of evil. Then you lose like 40 points instead of whatever. So I tell you what the derivative is supposed to be. So if you can't do it, you can still do the rest of it. Yes? And I'm going to do that in a quiz, test, blah, 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 blah. Okay. The downside to that is students think they're wrong. When is it going to start to look like this? When you are done. It is not going to look like that until you are done. So people go, it doesn't look like, yeah, you're not done yet. That 18 is going to come out of freaking nowhere, right? Probably the x minus 1 is going to come out of nowhere. You're not going to see it until you're done. You guys with me? So don't think in the middle, I must be doing this wrong. I don't see 18. I don't see what the shit is this guy doing. No, you got to get all the way. So go for it. Take that guy's derivative and see if you can get it to be that. You can all hope that I didn't take this. No, I didn't. I double checked. I had Wolfram out to do it for me to make sure. Yes. You can do another piece of paper, obviously. It's not a quiz or something. There's not enough room. Huh? Yeah, totally. Right. Are you guys to the point now you can see what's the main rule you're going to use to begin this thing? Product. This is stuff times stuff. Product. I don't give a shit what's involved in either of this stuff. It is the product of two functions. Product. If another rule comes up, I'll worry about it then. Okay. Don't try to cram it all on the paper. Use your own paper. Not much room up there. Well, the derivative is the first step. It's the factoring that most often gets people. does the power do after that? You didn't put it back on. You didn't make it 4 in front of x minus 3 cubed.
That's got so it's just before.
No. Anything to the 4th power. 4 comes down in front of it to the 3rd power now. Then you won't be able to distribute the 4 because it'll be to a 3rd power. Yes? Okay. Yeah. Only one thing missing here. Yep. I mean, you could, but you're in the inside. This one, you're in the inside. Shoot, or you got another one. Right. There it is. Yeah, sure. This looks good. This looks good. Maybe not change. So we took out 3 of these, 4 of those. I like it. It's really good. So you put this here first. So you put 10, one of those, plus 4, one of those. Okay, I like it. See how you figured that? So you started getting the zeros before you finished the factor. Do you see how you could take an 18 out of this? See what I mean? Don't you have x minus 3 cubed? Don't you have 2x plus 3 to the 4th? Wouldn't you have, if you took an 18 out, what would this be?
Oh, you put it in front of everything.
Yep. Took an 18 out, you can take that coefficient, you can take that constant and put it out, yeah. Oh, no. Forget it. This is f and this is g. It's f prime times g plus f times g. So this is f prime. You didn't multiply it by g. And this is g prime. You have to multiply that by f prime. F prime times g plus f times g prime. That is just f prime. It's not times g. Yeah. Doors? Here, bro. Oh, the only mistake you made so far is this is a chain rule. There is the inside side. 2. So that should come out to make that 10, right? So that has to be chain rule because the inside is 4 than just x. This is just x, we got one slope, so its derivative is 1 here. That's the only mistake so far.
So, but I do that right then?
Right when you take its derivative, at the end it should say times 2. Because that would be times the derivative inside, right? So the 5 comes down, goes to 4 times the derivative inside. Yes. And then times the other function, yes. Good. What's up? Oh, I'm still recording. It's a very exciting part. Derivative, 2 things, so very quickly. This is product rule. So if I take the derivative of this guy, the 4 comes down in front of stuff to the 3rd power. Derivative of stuff is 1, so I don't have to worry about that part, times the other one. Plus, the 5 comes down in front of 2x plus 3, the power goes to 4, times the derivative of the inside function times the other function. So that's product rule, and right here, this is chain rule. This piece right there. So I could actually just start factoring it now. What number comes out? No. Not how many x minus 3's come out. What number comes out?
2.
2. How many x minus 3's come out? 3. He could give 4, but this guy has only got 3. How many 2x plus 3's come out? 4. He can get 4, he can get 5. That's nice for him. He can only take 4. Yes? I need you to embrace. If you embrace, I gotta continue that sentence. Embrace how easy this is. The derivative could get a little tricky. You could forget chain rule, I understand. It's easy to forget chain rule, poor little chain rule. But all we're doing now is I've got two terms. Both are a little overloaded, but I've got two terms. And they got shit that's similar. They both have a 2. Take it out. They both have 3x minus 3s. Take them out. They both have 2x plus, they have 4 of these. Take them out. That's how GCF works, right? Take out the most of each shit you can take. The way that product rule works, you're guaranteed to have common factors. Yes? When we have this kind of function, I should say. So what's left here number-wise?
9.
Who? What's left here number-wise? 2, because there was a 4. And took a 2. How many x minus 3s left? None. How many 2x plus 3s left? 1. Plus. Took that 2 out, right? Good. 5. How many 2x plus 3s are left? None. How many x minus 3s are left? 1. So then I got 2x minus 3 cubed, 2x plus 3 to the 4th. 4x plus 5x is 9x, 6 minus 15. And can you see how I can take a 9 out? Some of you guys didn't take a 2 out. So you got 18x minus 18. You can take an 18 out. Who cares? Eventually the numbers are going to come out. Yes? So if I take the 9 out, I end up with that. Stop for a minute. And again, don't waste a lot of time here on a test or a quiz. If you don't get it pretty quickly, say I'll come back to you if I got time. And then you can just take the derivative I gave you and just start doing the other work. Some people, I've literally talked about this. This is why I'm staying on this for a minute. And they don't do this and they put I couldn't do it. I'm like, I gave you the thing. All right, is everybody with me? I gave you, I'm going to give you the derivative. You're going to lose points if you can't get it, but just do everything else you can, right? Okay. What are the critical numbers?
3, 1, and negative 3 halves.
Yeah, in general, how do you find the critical numbers?
Equal to 0.
When the derivative is 4. So it gets really tricky because we end up doing a lot of functions like this. It's got nowhere where it's undefined. It's a freaking polynomial, yes? It's not going to be undefined anywhere by definition. That's the only kind of things we call polynomials. But in general, you have to also think, where could this be undefined? You don't want to just suddenly forget that's part of it. Like we saw earlier, we had that geek where things happened, yes?
Like vision or like rat or like you're doing vision essentially.
Oh, sure. Very often it's if your original function had a fractional power, you could end up with undefined areas.
Fractionals or straight up division or anything like that. If there's anything like that,
Then you could have some undefined places.
yeah, that's
Exactly.
usually what's happening.
All right, so I'm sorry. What were the critical numbers again?
1, 3,
Yeah. 1, 3,
negative 3 halves.
negative 3 halves. Kick ass. All right, let's see. Make a sign diagram. So I got negative 3 halves. I got 1. I got 3. And each of them is the location of a 0 slope. I don't care about scale, just please, dear God, put them relatively. People mix them up and then you get the funkiest looking graphs. What do I do now? Yeah, so real quick, what's the only root that comes from something with an even multiplicity? What's the multiplicity of 3? 3. It showed up 3 times, correct? X minus 3, X minus, I got 3 times. What's the multiplicity of 1? 1. Those are both odd. What's the multiplicity of negative 3 halves? 4. Okay. So that's the only one that's going to stay the same sign on either side of negative 3 halves. If you don't care about multiplicity, again, I will cry because it helps. It's really powerful. If you care about it, then you can just plug numbers in everywhere. So I'm going to do both. So if I plug in, where do you guys want to start? I don't care. What I always do is I plug 0 in if I can. So what do you get when you plug a 0 in?
Positive.
Don't worry about the AT. So when you plug a 0 in here, you get negative,
Positive.
positive, negative. Negative times positive times negative is positive. So it's positive in here. Is everybody with me? If you plug a 0 in, I don't care about the number. It's going to be negative times positive times negative. If you want to be more specific, it'll be negative 27 times 81 times negative 1. But again, I don't give a shit about the number. We only care about positive and negative because it was the only thing we want this to tell us. If the function is going up or down. That's all we care about at the moment, right? Okay. Now me, I would go like this, because I'm weird. I would say, oh, this is the guy, even, he's going to be the same sign, then it's going to change, and then it's going to change. Now, if you want to, you could plug other shit in. What do you get when you plug a negative 5 in? Negative? Yeah, positive? Negative. Negative times positive times negative is positive. Yes? And you can keep doing that. Are you with me? So if you don't like multiplicity, if you're like, I'm not going to do that, man, don't. That's great. Then you have to check each freaking region. Me, I can just do what I did. I'll put a 0 in, figure it out, and then pop, 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 based on multiplicity. Okay. Is everybody okay? Does everybody see what's happening? How could you figure this out if you didn't like my multiplicity approach? Just plug in a stupid 2, right? Negative times positive is negative. See? So it lines up, yes? Then you can plug in 10 billion. Positive times positive times positive is positive. Okay. Underneath here, going up, then for a moment it is going up, then for a moment it is flat, then it is going up, then for a moment it is flat, and then it is going down, and then for a moment it is flat, and then it's going up. Okay, so what's happening here? Is this a local extrema? No, that's a tricky dude. Screw you. Didn't like that number in the first place. What is this happening here? It's a max. Up to it, down from it, but the visual is nice, yes? So how do I determine what point is the max point? Where do I plug 1? To the original function, because I want to know where the function is. If I want to know where the function's headed, where it's going, I put it in F prime. Well, I want to know where it is, I plug it into F. Yes? So when you plug a 1 in, I don't know, you get 16 times, oh God, fudge, 5 to the 5th. Good job, Jeff. Wait a minute, let me think. 5 to the 5th times 2 to the 4th is 10 to the 4th times 5 is 50000 is 50,000. I don't know, is that right? I don't know. What's 5 to the 5th times
Oh yeah, it's
16?
3,125.
What is it?
3,125.
Is what?
5 to the 5,000.
Now take that and multiply by 16.
Oh, okay.
Yeah. If I remember correctly. Yes, 16.
Yeah, 50,000.
50,000, okay. 50K. Okay. We put underneath 50,000. Okay. And then how do I get the minimum? It's at 3 comma. When I plug a 3 in, this is nice. When I plug a 3 in, I get. When I plug a 3 in, I get. When I plug a 3 in, I get. When I plug a 3 in, I get.
0.
When I plug a 3 in, I get. It should be easy as shit. It should be quick. You should not be thinking. You should not be plugging anything in. You get freaking 0, of course. First factor is 0. I don't give a shit what anything else is. It's freaking 0. So we go from 50,000 to 0. So this is a max. This is a min. This is a screw. Yes. Okay. How do I find the intervals of increase, decrease? They're just staring me in the face, correct? What are the intervals of increase? From what to what?
From negative infinity to 1.
Almost. I'm really sorry, Paola. Paola. I can't speak. I apologize if I had it done. You kind of fell into my trap. What is it doing at negative 3 halves? At negative 3 halves, is it going up or down? Neither. So where is it increasing? From negative infinity up to? Negative 3 halves. Good, because it takes a rest. Or a little 2. And then from negative 3 halves to 1, and then from 3?
Positive infinity.
Alright, so the only place it's decreasing is from 1 to 3, the part that are left out. Bam, bam, bam. Or over you can see it. So we already know, if I kind of made these arrows a little more curvy, I know it goes, you know, I can kind of trace it out if I make them curvy. And I know this is polynomial, so it's not going to have any weird places. I know it's going to look like Loch Ness Monster. Yes? Okay. The one thing I didn't talk about yet is this guy. Do you guys remember the worksheet we did last time? Where could absolute maxes and mins occur? If you look at that worksheet we did last time. You have the A, B, C, D stuff. Yes?
On the end.
Endpoints and critical numbers.
Critical numbers.
So here's the great thing. I need you to start to love the shit out of absolute maximum. I don't have to do anywhere near as much work as we just did. The absolute max and min, I get the critical numbers, I get the endpoints, I plug them all in, and I see who wins. Who won the biggest and who won the smallest, right? So what is f of 0? That's an endpoint, yes? So I gotta check 0, 2, what else, Jeff? I don't have to check negative 3 halves, because we already know that's a, yeah. I gotta check, oh, I'm sorry. We're in between 0 and 2. So what's the only critical number that's between 0 and 2? 1. So be careful, don't do anything outside of the interval of interest. So what's f of 0? No. What's f of 0? That's the thing we just got, isn't it? F of 0, 50,000? I'm sorry, not 50,000. What is f of 0? It would be 81 times 3 to the 5th. So it'll be 3 to the 9th, which is what, math boy? I don't freaking know. It's 81 times 81, which is 6,400, 6561 times 3. What is 3 to the 9th? Anybody?
19,683.
19,683?
Yes.
Sounds good. What is f of 1? We already know that. That's 50,000, yes? And what is f of 2? 2 minus 3 is negative 1 to the 4th is 1. What was it? 2 times 2 is 4 plus 3 is 7 to the 5th. Whatever 7 to the 5th is.
16807.
What is it?
16807.
16807?
Yeah.
So who won the challenge for the highest? Yep, this is the location of the absolute max, and who won the lowest?
2.
Yep. So the absolute min, where'd it go? 2, 16,807. Okay. Sorry the numbers got big. Kind of made that a little bit harder to see, but the numbers got big. Who cares? Local maximum sucks. They're beautiful, but it takes more work. You have to do the sign diagram, you have to do blah, 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 so you can see what. Absolute extreme, if that's all it wants from you, go, thank you, problem. Find the critical numbers, take the endpoints, shove all of those in, see who wins. Absolute extrema, cry a little tear, go, thank you. Because it's gonna be a much easier problem. Local's not that much harder, it's just more work. So what I want you guys to do, I'm gonna put you in groups. Some of you guys might have already done some of this, but that's great. You can help everybody else out. I want, what do you want, Jeff? I want Ezekiel, I want you, maybe you can move up here and work with these guys. You can do that, good. And then you can turn around. My guys in the back row, I don't care. Can one of you guys work with the two here in the middle, and then the other one work with the two over there? I'll let you guys sort yourselves out. You guys, I want you to turn and work with people behind you. Same thing there, yes? Turn and work with the people behind you. You guys should be on to what's happening. Yeah, you can come up here if you want to. So, I want to suggest this. What was the one algebraic topic that I told you was going to be really important?
Power.
Listen to me. If you have trouble with factoring, focus on that shit. We have this whole place, it's called a sissel. If you go in there and you say, hey, listen, hey, that's great. You got all that, that's great. I need to work on factoring, help me. Whoever's in there will give you stuff, we'll sit you down, let you watch videos about it, let you do practice tests, we'll sit down with you. Do you guys understand? Any topic that's related to what you're trying to do in here, you can go there and just say to the person, hey person. And the reason I want you to understand is, Math Science Center doesn't work that way because they're just students who are tutors. They're not used to making stuff over the fly. They don't have a whole back catalog of handouts they can go print out for you. You with me? In the freaking CISL, those are instructors. They have tons of handouts on anything. And they have shit that's in the room with them. So I mean, if you go in and say, hey, I just want to focus on factoring. Can you just help me focus on factoring? They have to do it. If they can't, go complain, because that's our job. Yes? You guys, you understand? I can't stress to you enough. You gotta know how to factor. Factoring is just one of those things, the minute you learn it, you realize it is everywhere. It is everywhere. Okay? So I'm not trying to make you feel anxious if you don't know factoring. At the same time, you should feel, you gotta get on it. Okay. I understand when things start to look weird, you lose touch of what it really is. That looks weird already. So let me just write it by himself so we can focus on just him. We identify this as product rule, right? So to be nice to myself, I'm gonna say derivative of the first times the second plus the first times the derivative of the second. You can immediately do that. There's so much not wrong with that. Because now I can just focus. Okay, look at that. Oh. Thank you, problem, right? Don't worry, I won't cry again. And then this guy, he's gonna be a little trippy, yes? But at least now I can just completely focus on him. Everything else doesn't matter. So, derivative of x is 1, that's crazy. Plus x times, okay, how do I take the derivative of e to the stuff?
E to the.
Yes, the derivative of e to the stuff is e to the stuff, but then? Yes? Can we stop for a minute? Can you guys see every step I just took? So,
Why you put another prime on it if it's already
Because that's the
prime?
next step.
what's the derivative of e to the stuff? E to the stuff times the derivative of stuff. Chain rule.
The next.
The inside function gets its own term, correct? Okay. Do you guys see what I mean by you don't have to know ahead of time everything you have to do? All that matters at first is it's function times function product. Well, I don't have to worry about anything else at first. That first step, do you all agree that first step was easy as shit? Primarily because I didn't do much. But I did a lot. I wrote the form of the rule. So I know all my parts are in the right place. I did the rule. I know all my parts are in the right place. Now I can just attack the individual parts. X prime. Tears again. Just to remember how beautiful X prime is. Done. This guy, shit! There's an inside function that's more than just X. Derivative of E is itself times inside function gets a term, yes? That's how chain rule is. Anytime the inside of a function is more than just X, it gets a term. And again, like I said, it always happens, but This guy just comes to the right, he's waiting very patiently. This guy comes to the right, he's waiting very patiently. What's the derivative of negative 2x squared?
4x.
Let me see if we can handle this. How many terms are there in what I just wrote? 2. How do you know so quickly? Because terms are separated by pluses and minuses. This has got chunk plus chunk. 2 terms. What do they both have in common?
E to the negative 2x squared.
I can take that out. If I take it out of itself, it's left with 1. And then if I take it out of here, I'm left with negative 4x times x, negative 4x squared. Which is what I was supposed to do. Thank the gods. Thank the gods. Now, am I done factoring there? But I left it up to you. There's 2 ways to move forward. So, very first thing we have to do, is everybody semi-cool with what just happened? Write the rule, then you can completely focus. What's the only thing in this whole thread? The only things I have to worry about? This and this. Everything else is just coming for the ride because it doesn't have anything to do. Do you see what I'm saying? I'm trying desperately to get you to be nice to yourselves, right? That's going to be the weirdest part at first. He's going to be the hardest thing. But it's an E. Anytime you see an E, you should go, oh, thank God. Because part of the answer is going to be itself. And then the derivative of the inside. Okay. Now, the next thing you have to realize is, what does E look like? Don't do this. What does E look like if you graph it?
He's a constant.
I like it. Just keep me honest. He's like, I know your tricks, man. I don't think you meant it, but that was a trick. What does e to the x look like if you graph it? I appreciate you going. Yes, so e to the x looks like, I think from your perspective, this. Yes? What's going on here?
It's an asymptotic.
Asymptote. At what? Yes, so can the output to an E ever be 0? No. You with me? Is there any value I can't plug in for x? Is there any value you can't square? Is there any number you can't raise e to it? No. So, does this give me somewhere that it's equal to 0? Can I make this 0? What did we just say? There's a freaking asymptote there. I can't go there, yes? Does this guy ever undefined? No. Does he give me any critical numbers? No. Do you guys see that?
Sorry, there's one thing that I'm a little confused about, because wouldn't, because 1/2 to the power of 2 would end up being 1/4, right?
Sure.
Times 4 would be 1.
No. Are we looking at this now?
Yeah.
Or are we looking at this?
Oh, you're looking.
I'm talking about this.
Oh, yeah, that one.
Yes.
Okay, sorry, I was looking at the other card.
Obviously, the other part's going to have 2 answers. Yes, I know that because it's got a square. Yes, so if you only got 1 answer, that's wrong. Squared, fundamental theorem of algebras, is going to have 2 answers. 2 ways you can find it, which is why I left it like this. You can either finish the factoring. This is not factored all the way. But I feel like most of us might have done this. Is that true? If you do this, and you do this, that is bad. What have you forgotten?
Plus or minus.
Yes. Because what do you square to get 1/4? Positive 1/2 or negative 1/2. So this is a shortcut. What that is a shortcut. How do I factor this thing? That's the long cut. How do I factor this?
1 plus 2x minus 1 minus 2x.
Yes, easy as shit. It's just the difference of squares. 2 terms, it can only be squares and cubes. Everything can be cut in half. So I do it, and I put plus minus so the middle terms cancel, because there is no middle term, yes? Difference of squares is always easy. Always, always, always easy. Negative 1/2, positive 1/2, yes? Shortcut means you have to be more aware of something. every shortcut means you have to be aware of when does it work, what kind of little tricks do you have to do. That shortcut, you gotta put a plus or minus because you're supposed to get a positive and a negative answer, yes? Okay. So, my only critical numbers are 1/2 and -1/2, yes? Okay. So if I make my sign diagram, I got my -1/2, I've got my 1/2. They both make the function 0, yes? I didn't have anywhere that made it undefined. Yes.
For e to the negative 2x squared, would you set the x squared instead of e to the x is equal to 0?
You can't make, alright, everybody stay with me. Do you understand that the power is -2x squared, right? But isn't that still e to a number, correct? I don't give a shit what that is, e to a number, correct? Everybody with me? E squared, e cubed, e to the 4th is just getting bigger, correct? The only possible place it could have a problem is negatives. What's e to the -1? I don't want a decimal. What's e to the -1? E to the is 1/e. What's e to the -2? 1/e squared. What's e to the -18 trillion? 1/e to the 18 trillion. What's the only way a fraction can be 0? It's the only way a fraction can be 0. If the top is 0. Do you guys notice what is always on the top? E to the negative. What's always on the top? 1. So it can't be 0. That's why there's an asymptote. Can it get tiny? Do you agree that 1/e to the 18 trillion is tiny? 1 divided by what I used to call BFN, big freaking number. 1 divided by big freaking number is small as shit, yes? 1 divided by BFN is SAS. Sorry.
Would it have that limit though?
Huh?
Would it have that limit to 0?
That's why it's got an asymptote. It's got an asymptote because it keeps getting smaller and smaller and smaller. It never gets to 0. Yes? Okay. So you will be held accountable for knowing what functions look like. I should have worn my little dancing dude shirt. Yes? You have to know the basic shapes of functions. You see now why that makes this problem doable. I'm like, oh yeah, it's an asymptote. Oh yeah, it can't be 0. Oh yeah, there's no critical numbers. Moving on. Not a big deal. Right? It's like real quick, here's a silly example. If I got to the point where I had 7, you can do it, Jeff. 7 times x minus 1, what's the critical numbers?
Was it?
1,
What does this give me?
0. Oh, nothing.
Why does that not give me any answers? Because 7 cannot be
Equals 0.
0. So anything that can't be 0 or undefined will not give me any critical numbers.
Well, e to the 1 is 0, right?
Hell no.
No?
Help me out. What's e to the first power would just be e.
Yeah.
And e is 2.71828, blah, 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 right? E to the 0 is 1. Yes, okay. I'll leave that.
So that
Both of you guys have to keep me honest. I like that. Okay. Is everybody with me? So listen, 7's obvious. You guys don't even think about why you skip it. But of course 7 can't be 0. It's freaking 7. But e to the -2x squared can't be 0. It's got a freaking asymptote. It can't get there. You can't get there. Okay. I love it. I love it. I'm not telling you what should be new, but this could be review or it could be something you forgot. Okay. So, what do I do now?
negative.
Personally, I would go, they're
Pick
both
a
odd
number.
powers, so I only have to check one thing. I would put 0 in. What do I get when I put a 0 in?
Just-
Yeah, this is always positive, correct? Do you guys see that? Because it can't even go to 0, so it's always positive. So I only have to look at this. When I plug a 0 in, this is positive, yes? When I plug in a 1, negative. And when I plug in a -1, negative. You guys see that? 1 minus 4 times 1 minus 4 times 1 is -1 squared is 1. So ready with me? Okay. And if you do the multiplicity, that would have been a lot quicker. What does that mean it's happening? Can you guys now do the sign diagram? This is going, I'm sorry, the arrows. This is going down, flat, up, flat, down. So now this is the mid at negative 1/2, comma, whatever the shit, and this is the max at 1/2, comma, whatever the shit. And of course, where am I gonna plug negative 1/2? In the original. Because now I wanna know where the function is, not which way it's headed. I'm not gonna pretend like I could do that in my head. Sure. Thank you. Maybe. Most of the functions we're gonna look at are gonna be like the first one we did, yes. We're gonna look at a lot of polynomials. Every now and again, we're gonna look at something that's got sine in it, we might look at something that's got e in it, we might look at something that's got natural log in it. But a decent bulk of them are gonna be polynomial stuff. Yes? Okay, so, yes.
So whenever we see anything to the power of x, like e to the power of x, just basically don't treat that as a 0.
Yeah, if I saw 3 to the x, I can't make it 0, I can't make it undefined. Okay. So, last new thought for the day. Last new idea for the day. I think I want to do it in this order. I think I'm going to come back and do 4-2 next time. I gotta be careful when I say that phrase. The phrase next time is like Pavlov's dogs, you start to pack up. I'm gonna talk a little more. So 4-2 we'll do next time. I wanna talk about, all right, f of x tells me where a function is. When I plug x in, yes? When I plug a value in. So if I plug a 3 in and I get a 5 out, I know the function is at 3, 5. I know that's the point it goes through. F prime, of course, tells me, there's a few answers you can give me. What's F prime tell me? Slope. Tells me where it's headed, correct? Tells me if it's headed up, tells me if it's headed down. If I just told you to draw the line that has a slope of 2, let me say this again. If I just told you to draw the line that has a slope of 2, how many answers could I get? How many lines have a slope of 2? This one does. So does this one. So does this one. So does that one. Do you see what I'm saying? If I just know the derivative, I only know how it's moving. I don't know where it is. That's a little quantum mechanical, but we won't go there. Does that make sense? F just tells me where it is. F prime tells me how it's moving. Yes? So let's investigate what F double prime tells me. Let's figure out what that might tell me. In fact, why does F prime tell me how things are moving? If you think about it as position, what would the first derivative be then? If I have a position function, the first derivative would be velocity. It tells me how quickly it's moving, yes. So F prime tells me the rate of change of F. If F is getting bigger, F prime is positive, yes? If F is staying the same, even if it's just for a moment, F prime is 0. If F is getting smaller, F prime is negative. You guys with me? When we take a derivative, don't we get a function in its own right? Do you all agree with me that 4x cubed is a function? Right? I don't know if some of you guys want. Yes? I don't know what you want to. 4x cubed is a function, correct? Isn't it the derivative of x to the 4th? You with me? 4x cubed is the derivative of x to the 4th. But isn't 4x cubed a function in its own right? Poor little guy. He's like, I know what came from that, but I'm my own person. I'm my own function. Leave me alone. You guys with me? So what is f double prime then? It is the derivative of f prime. F prime tells me how quickly f is changing. F double prime tells me how f prime is changing. So it tells me how quickly the slope itself is changing. So for a line, does the slope change? If my line was 5x plus 2, what's the slope? 5. And of course we know that from algebra, or if you do the derivative, you get 5. What's the derivative of 5? Second derivative is 0, because is the slope changing for a straight line? No. So of course the second derivative is 0. You with me? Or you guys we really with? Okay. So, if I have a function, let me draw a standard little dude here, little Loch Ness monster. Open the door, there's a Loch Ness monster. Sorry. It's an inside joke for anybody. When I talk about derivative, we've done that already. It's going down, it's going up, it's flat, blah, blah, blah. Now I'm going to talk about second derivative. And that's all about how the slope itself is changing. Yes? Let's get some colors going on here. Why not, Jeff? Let's go crazy. Oh, I can use red. Fine. All right. My red pen that I don't use anymore. All right. What would you guys say about the slope here? What about the slope here?
Increase.
Is it more or less positive?
More.
Okay, so this is going to be a little tricky. I am talking right now about how the slope is changing. What happened to the slope from that first point to the second point? It got bigger. So the second derivative should be positive there. Does that make sense by itself? Whatever I'm looking at, if it gets bigger, its derivative should be positive. I happen to be thinking about f prime. I'm talking about the slope, but its derivative has to be positive. Are you guys with me? Which means f double prime is positive there. Let me say this again. I might have said too much there at the end. Do y'all agree with me? What the slope is positive here? It's positive there. The difference is it's more positive here, correct? So from this point to that point, the slope got bigger. So the derivative of the slope, f double prime, has to be positive. How we doing? Do you agree that at some point around here, it starts to do the opposite? So at some point in here, after that point, that's positive. What is it here? Still positive, but it is
Getting less positive.
getting less. So therefore, what should be true about f double prime here? It was big positive, now it's smaller positive. F double prime has to be negative because the thing I'm looking at is getting smaller. If I'm looking at f and the function itself is getting smaller, f prime must be negative. If I'm thinking about the slopes, which is f prime, and the slopes are getting smaller, the derivative of that, f double prime, must be negative. Okay. Taking the derivative of something always means the same thing. It's the slope of that thing, which is the rate of change of that thing. So what is f double prime? It is the derivative of f prime. Let me say that again. What is f double prime? What's the second derivative of f? It's the first derivative of f prime. Yes? Okay, I like it. So there's an analogy between how we think about f and its slope and how we think about slope and its slope. Yes? Now we're talking about the second derivative. So now watch, this is kind of cool. Do you all agree that somewhere in here it went from increasing slope to decreasing slope?
Yeah.
Somewhere in here it is the most positive slope for that area. Yes? Somewhere there goes, I am the most, oh man. Yes? So, do you agree? This whole region, you ready? What's the slope here? It's big. Negative. The slope here is still negative, but is it as big negative?
No.
Is it increasing or decreasing then? If your profit was negative $1 billion and then it was negative 500,000, did your profit increase or decrease? It increased. Yes? So, just to make sure I didn't mishear a few people. If I'm here, big negative, and then I'm there, I'm not as negative. My slope increased. So the second derivative will be positive, yes? My slope got bigger. So the derivative of my slope must be positive. Do you see how it's going to be all the way through? Right? And here's the cool thing. That is the technical truth behind second derivative. But notice, this whole region looks like a frickin' smile, don't it? Look, he's smiling at us, right? What's that dumb movie, Smiley, whatever the shit, but it's not going to come get you. I don't even know the point of that. Over here, what's over here? So this whole region, F double prime, is greater than 0. Yes? Why? Because the slope of my slope, the change of my slope is positive. It is getting bigger through that whole region. After whatever weird point here, what's it start to do?
Decrease.
Now the slope is getting smaller. It is still positive. It's like me moving in my car and then I step on my brake. I'm still going forward, I'm just going forward slower. My acceleration is backwards because my rate of change of position is getting smaller. Yes? It's decreasing. Okay. And do you see how it's going to continue? What's happening to the slope all the way around this curve? Is it getting bigger or smaller?
Decrease.
Is it getting bigger or smaller, my slope? Smaller. And of course, this whole region, this weird, freaky, stringy hair dude. Yes? It's weird. This is where F double prime is less than 0. And what's it look like? It looks like a frown, everybody. Do you guys see that? So we're connecting the mathematical interpretation of F double prime with the visual. The visual kicks ass. If F double prime is positive, it's doing this kind of thing. It's what we call a cup up. Could this hold water? And I haven't said water yet to you guys. That's how I say water. I'm sorry. Does this hold water? Does this bowl hold water? Yes. If somebody comes up to me and wants a porridge and they hold a bowl like this, is that going to go well?
I want some soup. Shit.
All right, so that's cup up, and you're not going to call this cup down. Okay, right? So when does it cup up? When the second derivative is positive. When does it cup down? Negative. This whole idea we call concavity. You guys have heard the word concave? You have concave and convex. If you look at a spoon, one side you're smaller, the other side you're bigger. It's concave versus convex mirror. Yes? Lenses have the same idea. So the concavity is exactly that. Concave, convex. So we don't talk about convexity. So it's the concavity of it. This is concave down, this is concave up. So some of you guys might understand what we're about to do. We do f of x, we get f of x, we get f prime, yes? We find critical numbers, we make a sign diagram, yes? Yay, we find our pluses and we find our minuses. Yeah. Then we do f double prime, we get our critical numbers for it, and then we make a sign diagram for it. Where it's positive, what's true?
It's concave.
I can put a little smile underneath it. It's going to be concave up. Where it's negative, concave down. Would you agree that these points in this little silly example are important? What happens at these points? What changes? Look at you. The concavity changes here, yes? So for the first derivative, those are maxes or mins. If it goes up and then down for the first derivative, that's a max. Down and then up, that's a min, yes? For second derivative, we call those inflection points. If you've taken any business, or you ever heard, sometimes the news says we're in an inflection point now. All that means is, on the graph here, the inflection point is where this was most positive in this case. Do you all agree? F double prime is greater than 0. We talked about that, yes? F double prime is less than 0. So what is it right in the middle? What's it got to be right in the middle? It's got to be 0. So when I set F double prime to 0, I'm finding these points of inflection where it goes from bending up to bending down. So if you're an economist, Inflection points are a very interesting place. Things are looking great. Wait a minute. So right when we see the inflection point, I'm like, whoa. Is it going to do this, or is it going to do another inflection point? Keep going. You guys kind of.
Depends on
So you hear it in the news sometimes. They even say in the news, inflection. No idea how you guys get news anymore. If the only location of news is TikTok or something, shit.
You need to.
Shit. Okay. I don't know. Sorry. You guys definitely don't read newspapers. I'm assuming. Right? You do sometimes? Kick ass. Some of them are good. Some of them are complete shit. All right. Sorry. How are we feeling about? Now, obviously, there's a lot of details to get into. All the details are going to flow from this idea, though. Yes? So this idea of the sign diagram, do you guys feel semi-decent about just once you get the critical numbers, the sign diagram should be relatively easy. Is that okay? This is going to involve second derivative, factor, critical numbers, another sign diagram. But now I interpret that sign diagram in terms of concavity. Yes? Okay. Oh. Okay, I think that's enough. I'm tired. I'm gonna stop class for me, and you guys can enjoy that. We just did 4-1, and we did a good chunk of 4-3. Next time I'll start with 4-2, and then we'll do more of this.